Build a URL shortener with FastAPI and Python. URLs can be long and unfriendly. This is where a URL shortener can come in handy. A URL shortener reduces the number of characters in a URL, making it easier to read, remember, and share. In this course, you'll build a URL shortener with Python and FastAPI. By the end, you'll have a fully functional API-driven web app that creates shortened URLs that forward to target URLs. In this course, you'll learn how to create a REST API with FastAPI, run a development web server with Uvicorn, model a SQLite database, investigate the auto-generated API documentation, interact with the database with CRUD actions, and optimize your app by refactoring your code. This URL shortener project is for intermediate Python programmers who want to try out FastAPI and learn about API design, CRUD, and interaction with a database. To follow along, it'll help if you're familiar with the basics of handling HTTP requests. If you need a refresher on FastAPI, then this Real Python course is a great introduction. So now you know what the course is going to cover, let's get started. Python URL Shortener Demo. In this course, you'll build an API to create and manage shortened URLs. The main purpose of this API is to receive a full target URL and return a shortened URL. To try out your API endpoints, you'll leverage the documentation that FastAPI automatically creates. When you post a target URL to the URL Shortener app, you get a shortened URL and a secret key back. The shortened URL contains a random key that forwards to the target URL. You can use the secret key to see the shortened URL statistics, or delete the forwarding. Your URL shortener will provide API endpoints that are capable of receiving different HTTP request types. Each endpoint will perform an action that you'll specify. On screen, you can see a summary of the URL shortener's API endpoints. The code you'll write in this course focuses on getting the app working first. However, having a working app doesn't always mean that the code behind it is perfect. That's why one of the sections in this course will refactor parts of the app. Note that your main goal in this course is to showcase the basics of FastAPI to quickly set up a REST API server without going into more advanced topics like async I/O in Python or thinking about performance. If you want to learn more about writing asynchronous code, then check out this Real Python course. And if you're looking for specifics on how FastAPI handles concurrency, then you can check out the FastAPI documentation. Remember that the full source code for this project is available as part of the course materials. To get the most out of this course, you should be comfortable with the following concepts: object-oriented programming in Python 3, working with JSON data, Python type checking, and handling HTTP requests. In this course, you'll build your app step by step, so even if you're not familiar with the concepts listed here, then you'll be able to follow along. This course was created using the software versions listed on screen. Any code that's seen in this course in the Python REPL will be run using the bpython interpreter, which offers a number of improvements over the standard Python REPL, including color coding. However, all of the code that you see running will work in the standard Python interactive shell, which is accessed typically by typing Python from a terminal where your virtual environment has already been activated. So now you've seen what's going to be covered in detail, in the next section of the course, you'll prepare your development environment. Preparing the environment. In this part of the course, you'll prepare the development environment for your FastAPI app. First, you'll create the folder structure for your app. Then you'll create a virtual environment and install all the project dependencies that you need for the project. Finally, you'll learn how to store environment variables outside of your code and how to load the variables into your application. First, you'll create the project structure. You can name the root folder of your project in any way you like, but on screen, you'll see it named URL Shortener Project. The root folder will be your working directory. You'll run the commands for your application from the root folder that you're in right now. The files and folders that you'll create will be located in either this folder or your apps folder, which will be created next. While you can call your project folder anything you want, it's important to name your app folder shortener_app. When you're inside your project folder, create a subfolder called Shortener app. The Shortener app folder will be the location that your app will live in. Later on, you'll add your app's source code into different files in this Shortener app directory. Your URL Shortener Python app will be a package named Shortener_app that will contain a number of different modules. To use Shortener app as a package, create a dunder-init.py file. Here's how it's done in Windows Terminal. And here's how it's done in a Linux or macOS terminal. This dunder-init.py file will stay empty throughout this course. Its only job is to tell Python that your Shortener app directory is a package. Note that without a dunder-init.py file, you'd create not a regular package, but a namespace package. A namespace package comes in handy when splitting the package over multiple directories, but you're not splitting the package in this project. Check out this Real Python course to learn more about packages. Dependencies are the Python packages that the FastAPI project needs to work. Before installing them with pip, it's a good idea to create a virtual environment. That way you're installing the dependencies not system-wide, but only in the specific project environment. Here are the commands for creating and activating a virtual environment on Linux and Mac OS. And here are the commands for Windows Terminal. First, you create a virtual environment named venv by using Python's built-in venv module. Then you activate it with the source command or the activation script, depending on the platform that you're on. The parentheses surrounding the virtual environment name indicate that you successfully activated the virtual environment. After you've created and activated your virtual environment, it's time to install the dependencies that the URL Shortener app requires. You'll use the FastAPI web framework to build the API, so it's no big surprise that FastAPI is the first requirement of the project. To run the API, you'll need a web server. That's what Uvicorn is for. It's a web server implementation for Python that provides an asynchronous server gateway interface. Web server gateway interfaces specify how your web server communicates with your web application. Traditional implementations like Gunicorn need to run multiple processes to handle network traffic concurrently. ASGI, in contrast, can handle an asynchronous event loop on a single thread, as long as you can avoid calling any blocking functions. FastAPI leverages the ASGI standard, and you can use the Uvicorn web server, which can handle asynchronous functionality. But as you'll see in this course, you don't have to write asynchronous code to use FastAPI. If you want to learn more about async I/O in Python and how FastAPI handles parallelism, then you can check out the concurrency and async await package of the FastAPI documentation at the link seen on screen. With the web framework and web server installed, next is SQL Alchemy. SQL Alchemy is a Python SQL toolkit that helps you communicate with your database. Instead of writing raw SQL statements, you can use SQL Alchemy's Object Relational Mapper. The ORM provides a more user-friendly way for you to declare the interactions of your application and the SQLite database that you'll use. Your application will also rely on environment variables. You'll learn more about environment variables later on in the course, but for now make sure to install python.env to load them from an external file. Finally, you'll use a package to validate URLs. As the name suggests, the Validators Library helps you validate values like email addresses, IP addresses, or even Finnish social security numbers. In your project, you'll use validators to validate the URL that a user wants to shorten. Note that the install commands here are singled out to explain why they're required. You can install all dependencies in one command by chaining the package names. Now that you've created a virtual environment and installed the Python packages needed for the project, in the next section of the course, you'll see how to use environment variables with your application, making its deployment easier and more secure. Environment variables. You're currently developing your Python URL shortener on your local computer, but once you want to make it available to your users, you may need to deploy it to the web. It makes sense to use different settings for different environments. Your local development environment may use a differently named database than an online production environment. To be flexible, you store this information in special variables that you can adjust for each environment. While you won't take steps to host your app online in this course, you'll build your app in a way that enables you to deploy it easily to the cloud in the future. If you want to learn more about deployment, then check out Python Web Applications, Deploy Your Script as a Flask app, or deploying a Python Flask example application using Heroku. Start by creating a config.py file with the default settings. First, you import Pydantic, which was installed automatically when you installed FastAPI with pip. Pydantic is a library that uses type annotation to validate data and manage settings. The settings class is a subclass of base settings. The base settings class comes in handy to define environment variables in your application. You only have to define the variables that you want to use, and Pydantic takes care of the rest. In other words, Pydantic will automatically assume those default values if it doesn't find the corresponding environment variables. In this case, you're defining the default settings for env name, base URL, and DB URL. Later, you'll replace their values with external environment variables. It's a good start to have these variables in place with default values. But since the values for your current environment, the domain of your app, and the address of your database are dependent on the environment that you're working in, you'll load the values from external environment variables later on. To show a message once your settings are loaded, you create get_settings. This function returns an instance of your settings class and will provide you with the option of caching your settings. But before you investigate why you need caching, save the config.py file and run get_settings in a Python interactive interpreter. If you get an error when trying to run the input command, make sure that your Python interpreter was started from within the project's root directory. The settings are loaded correctly when you call get settings. However, you can optimize the retrieval of your settings a bit more. Your app settings are not changed while running the app, but still you're loading the settings over and over again every time you call getSettings. You can take advantage of getSettings being a function to implement a least recently used strategy. When you start your app, it makes sense to load your settings and then cache the data. Caching is an optimization technique that you can use in your applications to keep recent or often used data in memory. You can implement an Lru Cache strategy to accomplish this behavior. First, you import Lru_cache from Python's functools module. The Lru Cache decorator wraps the getSettings function. This allows you to cache the result of getSettings using the Lru strategy. You can see how this works from the Python REPL. Now you see the loading settings message only once. That means that your settings are successfully cached. By adding the Lru Cache decorator, you made your app faster while decreasing the load on computing resources. Another improvement that you'll implement is loading external environment variables. Start by creating an external .env file in the root directory of your project, and then add the content seen on screen. By storing your environment variables externally, you're following the 12-factor app methodology. The 12-factor app methodology states 12 principles to enable developers to build portable and scalable web applications. One principle is to store the configuration of your app in the environment. This includes resource handles to the database, memcached and other backing services, credentials to external services such as Amazon S3 or Twitter, and per deploy values such as the canonical hostname for the deployment. The 12-factor principles require strict separation of config from code. Config varies substantially across deployments, and code does not. It's recommended to have different .env files for different environments. Also, you should never add the .env file to your version control system, as your environment variables may store sensitive information. Note that if you're sharing your code with other developers, then you may want to show in your repository what the env files should look like. In that case, you can add a .env sample to your version control system. In .env sample, you can store the keys with placeholder values. To help yourself and your fellow developers, don't forget to write instructions in your README file on how to rename env sample and store the correct values in the file. The configuration variables that you used in your settings class are a fallback for your external environment variables. In the env file, you're declaring the same variables for your development environment. When you deploy the application to the web, you declare the environment variables for each environment. To load the external .env file, adjust the settings class in the config.py file. With the addition of the config class with the path to the env file, Pydantic loads your environment variables from that .env file. Test your external environment variables by running the commands seen on screen. Now you can see that the variables are the ones that you declared in the env file. Your app now works with external variables. With all of these previous instructions followed, then the directory tree should look as seen on screen. The URL Shortener project directory contains the Shortener app folder. In that folder at the moment, there are two files, an empty dunder-init.py file and a config.py file. In the URL Shortener project folder, you'll also have your virtual environment and the .env file you created in the previous step. So now that everything's in place, in the next section of the course, you'll start setting up your URL Shortener. Setting up the URL Shortener. Now that you've prepared your development environment, it's time to set up your URL Shortener app. In this part of the course, you'll create a FastAPI app with your first API endpoint. Once the app is running, you'll define what your app should be able to do. You'll model the data schema into a database, and at the end of this step, you'll be able to shorten a URL and see how your app forwards the URL to the target. Now you know what we covered in this section, let's get started by creating the FastAPI app. Creating your FastAPI app. As is traditional, start with a Hello World implementation of FastAPI. This implementation is a FastAPI app that has one endpoint. Create a file named main.py in the Shortener app folder and add the code seen on screen. First, you import FastAPI. You define app by instantiating the FastAPI class. The app variable is the main point of interaction to create the API. You'll refer to it multiple times during this course. Here, you use a path operation decorator to associate your root path with read root by registering it in FastAPI. Now FastAPI listens to the root path and delegates all incoming GET requests to your read root function. The read root function returns a string. This string is displayed when you send a request to the root path of your API. The code you just added to main.py is the start of your application. As you know, to run your app you need a server, and you've already installed Uvicorn. Run the live server using the command seen on screen. You tell Uvicorn to run app of your Shortener app's package main.py file with the command seen. The reload flag makes sure that your server will reload automatically when you save the application's code. This automatic reload is handy as you don't need to stop and restart the server each time you make a change to your code. Instead, you can just keep this terminal window running in the background. Now that the server is running, go to the URL seen on screen and check that you get the correct response. When you navigate to this URL, you're sending a GET request to the root of the FastAPI app. The response is the welcome message that you defined. Congratulations, your app is working. One of FastAPI's great features is that the framework automatically creates documentation of the API endpoints for you. If you go to the URL seen on screen, you will see the Swagger UI documentation that FastAPI has created. Swagger UI not only gives you an overview of your API's endpoints, but it can also be used to test the API. You'll leverage this functionality throughout the rest of this course to keep tabs on the API's behavior. With a bare-bones FastAPI application up and running, in the next section of the course, you'll decide what the app will do.